let us continue discussing in finding the vector sum using graphical method. Now, if you remember in our part 1, we discussed on how to find the vector sum using the parallelogram graphical method. Now, in this part 2 video, we will discuss on how to calculate the vector sum using another method of graphical, which is the polygon method. So if we consider an object here, and this object was applied by a force F1 with an angle of theta direction, and suppose we have another force, let us say F2, in the direction of beta from the positive x-axis, and we have another vector F3 with an angle of gamma from the positive x-axis in quadrant 4. Now the question is, how much is the vector sum of these three vectors? Now if we use the method of graphical parallelogram method in this problem, then first thing to do is to combine first the two, then after that the sum will be combined to the another one. So therefore you have to do finding the vector sum using the graphical or parallelogram method. Now what if there are another method or another vector? So therefore it means to say that you have to do another parallelogram method for the fourth. So F1 and F2 using parallelogram method, then find the vector sum. Then the vector sum of F1 and F2 should be combined with F3 using parallelogram method. So find the resultant of the 3. Then after that, the result will be combined again for another vector. So if you want to have to calculate this vector sum in a simplest way, I would recommend to use the polygon method instead of the parallelogram method, because the parallelogram method is applicable only for 2, but when the force is 3 or more, then it is advisable to use the polygon method. So what is a polygon method? Now, a polygon method is a kind of process of finding the vector sum. Now, all you need to do is to connect all the vectors into a closed polygon, which means to say that we will connect this force F1 and F2 and F3 but by a tail and tip principle, which means that the F2 should be constructed at the tip of F1, then F3 should be constructed from the tip of F2, and so on. Then after that, you have to close the polygon, and the closing line of the polygon is the resultant. Unlike the in parallelogram method, in our part 1, we created a parallelogram, meaning that's by constructing equal vector with opposite, then another vector to the opposite, then the intersection of the constructed equal vectors connecting from the origin towards the intersected line point, then that will be the resultant. In polygon method, you have to connect everything, and after that, so meaning you have to decide the starting point. Now take note that this is graphical, so you have to do it in a drawn to scale, which means that again you need protractor for the direction or the angle, and we need the triangular scale or ruler for the magnitude. So since this is graphical, again we need to have the scale so that your drawing will be drawn to scale. So the starting point of your graphical will be at any point. For example, we will start at this point. So then all you need to do is to construct F1 at this that origin. So when you have to do the constructing the parallel or equal vectors of f1, then put it here. So do it. You have to start here. So therefore you have to draw that equal vector. So same magnitude and same direction. Then after that, you have to connect this f2 to the tip of f1. So you have to construct again the Cartesian. Then draw the equal vector of f2. Put at the tip of the f1. Then f3 should be constructed at the tip of f2. So therefore, you have another Cartesian. Make sure that these are parallel to the x and parallel to the y. So then, okay, so since we have already three forces f1, f2, f3, this is an open polygon. Now take note that polygon method is a kind of a closed polygon. So the closing line will start from the starting point, then it will end up to the tip of the last force. So connect a straight line from starting point to the end point, and that will be our magnitude of the resultant. The direction of the resultant can be obtained by measuring the angle from x, this one, towards the line of action of the resultant. That's it. Now, take note that we constructed a polygon. We started with 1 and f2, f3. You can rearrange this one. It is not necessary to follow the order. There is no such order base. You can do anything as long as you are constructing an equal vector. So, therefore, suppose instead of having f1, we can start at, let us say, f3. I will use f3 as my starting point. So, you can transfer this one, f3, here. Then you can connect f1 or maybe f2 at the tip of f3. Then finally, f2 will be at the tip of f3. Then that you will end with the same point. So that's right. Suppose this one, this f3, put it here. Okay. Then you can choose any f2 or f1. Construct at the tip of f3. Let us f1. Connect it here. Okay. So then finally, connect f2 to the tip of f1. And that will be our endpoint. And it intersects at the same point. So therefore, there is no arrangement of the, you can choose as long as all forces, all vectors are put in the polygon. It should be a closed polygon because the closing line will be our resultant. Now, if you start at a certain point and you end up with the same point, meaning there is no resultant. So therefore, the forces are balanced. We call it as equilibrium. Now, if we have the resultant, then therefore, that particle will be displaced. So in this example, since this is the direction of our R, so therefore this object here, applied to these three forces, will move in the direction of R with a magnitude of R. This is the polygon method. And take note, this is drawn to scale. All angles must be properly measured using the protractor, and the magnitude should be in measuring scale or the triangular scale or ruler. But take note, we need to establish your own scale depending on the drawing area. So in order to understand, we will provide the example. Suppose we have three vectors f1, f2, f3, and it has the magnitude and direction. F1 has a magnitude of 100 gram force in the direction of 30 degrees northern part of west. Okay? So then F2 has a magnitude of 150 gram force in the direction of 50 northern part of S. Then F3 has a magnitude of 1.20 gram force in the direction of 12 degrees southern part of S. So the question is, what is the vector sum, or calculate the resultant? Now, again, there are many methods, but in this problem, we will solve this using polygon method. So, your starting point will be you have to choose your own scale depending on the drawing area. So I rather choose the scale of 1 centimeter is to 20 gram force. So again, recall our previous video that the meaning of scale is means that for every centimeter there are 20 gram force. So physically, 1 centimeter is equivalent to 20 gram force. This will serve as our conversion factor, and this is also the instrument to convert the 100 gram force in terms of cm, 150 in terms of cm, and 120 in terms of centimeter also. So do the conversion. So for F1, we have 100 gram force. Multiply it by the ratio. So the ratio means 20 should be denominator so that we can cancel the gram force. Then take note that we are allowed to use 20 over 1 centimeter. But take note, you cannot cancel gram force. So in this case, we can cancel gram force. Then meaning you have to divide the 100 by 20 and we have 5 centimeter. So the 5 centimeters is actually equivalent to 100 gram force. Okay, for F2, we have 150 gram force. Then multiply again by the ratio of the scale. 1 centimeter is to 20 gram force. Then again, we can cancel the gram force. Then divide the 150 by 20. The answer is 7.5 centimeters. Then for F2, the 120 gram force converted to centimeter. So therefore, you have to divide by 20 again. Cancel gram force. And the answer is 6 centimeters. These are the scales that we use. This is the dimension or the magnitude. So we will be using ruler. So again, you have to use the centimeter. Okay, so therefore, again, you have to start at a certain point. So take note, direction is north, south, east, west. So for the first force, we have the 100 gram force. So in the direction of 30 degrees northern part of west. Where is the northern part of west? This is the west. Then the northern part is here. So you have to measure 30 degrees here. So in order to come up with a drawn to scale, we need to use protractor. Then find the 30. So 10, 20, 30. So mark your pencil here. Then connect a line from here, the straight line. Okay? So this is now 30 degrees drawn to scale. And we need 5 centimeters for the magnitude because the 5 centimeter is equivalent to 100 gram force for F1. So use ruler. Ruler, find the 5 centimeters. So 1, 2, 3, 4, 5. Okay, so then mark your pencil at 5 centimeter. Then connect a line from initial or from starting point towards the point of the 5 centimeter. This will be a drawn to scale 100 gram force. Okay, so therefore the force is 100 gram force, but the scale is 5 centimeter. So next is to connect F2 or maybe F3. You can choose any. So to do it, you have to do the Cartesian at the tip of the vector F1. So then again, we need to construct this one, the 150, the direction 50 degrees northern part of it. So in this case, we are already displaced at this point. So therefore, this is east, west, north, south. So the 50 degrees northern part of east is coming from east going to north. The northern part, there are two parts of east. We have the northern and southern. So this will be, the angle should be measured here going to the north. So 50 degrees. So this should be 50 degrees. Now take note that this is 30. So therefore, this is also 30. Okay, two lines, parallel lines cut by transverse line. This angle must be the same. So meaning this should be between 30 and we will construct an angle of 50. So the total must be 1 out. The total must be 80. So 30 plus 50, 80. So this is to minimize the error, no? Instead of having the Cartesian, I discussed this in our previous video. So you have to count 8, 10, 20, 30, 40, 50, 80. So therefore this is 80. More or less. Okay. So therefore, then after that, you have to draw a line. Okay, this is 80 degrees. Then draw a line Draw a line. So this is now drawn to scale, which means that this angle from S is already 50 degrees. Why? Because this is 30. So we add 30 and 50. So this is a drawn to scale. Then for the magnitude, use the ruler again. Then find the 7.5. This is the point 7.5 centimeters. So therefore, remove the ruler. Then connect a line. And this is a drawn to scale 150 gram force. Okay, so the two vectors are already connected tail to tip. So then connect the last force. Again, you need to construct the Cartesian again. But take note, do not depend on Cartesian because anytime you will be creating error in that. So this will be our guide only. So okay, so same as before, we need to what? We need to construct the last force. If 3 is 12 degrees southern part of S. Where is the southern part of S? This is the southern part of S. Because as I've said, there are two parts of S. We have the northern part, it is above, below is the southern part of S. So you have to find the 12 degrees from S, and that will be our work. So therefore, protractor. But take note, okay, this is 12, this is 12. So the complement is 78. So therefore, this must be from the south going to east should have the angle of 78 because 78 is the complement of 12. So therefore, 78 added by what is this angle coming from east south to west? This one. Okay? Take note that this is 50. Okay? This is 50. So therefore, this is also 50. So the complement of 50 is 40. So 40 plus 78, 78, take note, this is 78. The complement of 12. It will add up to 118 degrees. So therefore, in the protractor, find the 118 degrees, then connect from the starting point, then mark the 118, then connect a straight line. So this is it. This is the drawn to scale direction of the 12 degrees southern part of S. Again, this is more or less, this is 12, this is not properly scaled. So this is 12 and this is 78. So therefore, the total is 118 degrees. So with that is we need to use the ruler again and find the how much? The 120 is equivalent to 6 centimeters. So put a mark on 6.6 centimeter point mark. Then conic a line, and that will be our drawn to scale 120 gram force, which is equivalent to 6 centimeters in the direction of 12 degrees southern part of S. So therefore, since we have already constructed all forces, if there are other forces, then connect again anywhere. Just follow the direction. Then since we have only 3, so this will serve as our endpoint and connect from start towards the end. And that will be our resultant magnitude. Then the angle of the resultant is coming from, you can measure here, let us say beta. So again, use the ruler, scale it, then use a protractor for the direction. Okay? So we will use ruler again. Ruler, find the distance. Then based on this record, you can create more precise than this presentation. Meaning you have to use pointed pencil. So in this case, we have 8.8 centimeters. So therefore, all you need to do is to convert this into equivalent gram force. Use the same scale. So R, which is 88.8 centimeters, will be converted to gram force. So you have to what? To multiply this by the ratio, but this time you have to reverse this one so that we can cancel the centimeters. So therefore, multiplied by 20 gram force per 1 centimeter. We can cancel centimeter. Okay, so then multiply, meaning you have to multiply 8.8 by 20, and the answer is 178 gram force. This is the magnitude of the resultant. Now, what about the direction of the resultant? Direction is, you can choose any, and this we can use this angle, measure this angle, or maybe this angle. This angle will be our northern part of S. This one is the north of this angle, then S, meaning the angle is in between. We call it as the bearing angle. the representation. Okay, so therefore, use the protractor. Based on this record, we found out that this is 36 degrees. So 36 degrees, this is 36 degrees northern part of S. This is the direction. Okay, so these are the solutions. If there are other forces, then connect until now. If this again, the end point will coincide the starting point, your resultant is 0. Take note, we can change the arrangement. There is no such order. It can be a complicated polygon. This is a polygon like, pero but we can do it in a cross directions, meaning just like what we did before. Okay, so therefore these are the solutions. So thank you for listening, watching this video. So in the third video, we will discuss the analytical method, the cosine law method, and the component method. See you.